Good morning, Afton. How's everybody doing today? Part 4. I say, just like Nightmare on Elm Street, you can call me Freddy Krueger, not because I'm in your nightmares, even though I know I am. I'm in your head. I was like, right here, we are talking about graphing polynomials. We're continuing to talk about this. So again, I wanted to give you guys a chance, give you a problem one more time. Try this one on your own. You have y equals negative. Notice it's negative x to the fourth minus x to the third plus 11x squared plus 9x minus 18. So go ahead and hit that pause button. Try this one on your own. All right, now that you're back, let's take a look at this right here. So problem 1, if we happen to look at the graph here for this, if I scroll over just a little bit, it's not too bad of a graph. I was like, it gives us a pretty good guess right here on where we think those are, -3, -2, 1, and 3. But we do want to confirm that right here. So looking at this, we see -3, -2, -1, and 3. Awesome. So we can go ahead and wrong color. -2, -1, 1, and 3. Degree is 4. Leading coefficient is -1. So my end behavior is down and down. I don't think we've seen it down and down yet. So -2, -1, 1, and 3. So I'm going to start with the down. And my graph's going to look something like that right there. That was kind of, now again, I didn't make mine as steep because again, I just need a small connection. It doesn't have to be the most accurate of things here. It just needs to be close. That's all I'm ever asking for on these graphs here. Now with this, recognize now I have 2 relative maximum. So that's why I need to make sure that I draw that graph just to help me indicate, oh, there's 2 high points. There's 1 low point. So again, I need to find those 2 high points and then the 1 low point. So going back to this right here, I was like, I can just kind of investigate where we were at. I'm going to start looking around. I said -1, -3, -2. -3, -2. Why didn't any of you guys speak up? My graph's wrong. Again, if I cared about it, I would cut this part out. 1 and 3. I don't care enough. I want you guys to see I am human. I am not a robot. I make mistakes. It happens. Okay. Graph still looks similar to what we had, but let's go ahead and let's get back to there. So between -3 and -2, I'm looking for that highest point right here. I can see looking at my graph. Again, I'm in the 4.8s here. That's 4.81. This is 4.83. So 4.83 is higher. So right here, here's one of my maximums, -2.6. 4.83. So -2.6 comma 4.83. Again, if you're slightly off here on this number, if that I always give you a 0.1 buffer is what I like to tell students. So if because of rounding or whatever, because maybe you looked at that and said, well, Mr. Keith, you were talking about rounding before. Shouldn't we definitely say 0.84? Sure. Again, I'm going to always cut you that slack when it comes to those problems there. So there's 1. Now, we could do the minimum right now, but I'm just going to jump to the maximum instead. I'm going to stay consistent here and just make sure we're finding the maximum. So again, in between, we can see, hey, we get up around 20. I have a few more guys in the 20s, and then that guy's back to 19. So I'm looking for that highest right here, 20.966. Again, if you said 20.97, makes sense to me. But we can see our other maximum is 2.2 comma and then 20.96. Write that in green. Hope you guys see it. I'm gonna write it in red. I'm gonna make sure you can definitely read it. Now it just looks like a mess, but 20.96. Did say 2.2, right? Okay. I doubted myself for a second. Okay, so now we still need to find that minimum. Again, looking at that minimum is probably around 0. Well, again, I can see, hey, I was like negative 18, but I get some negative 19s. Then I'm back to negative 18, so I'm looking for the highest in this area. Looks like we have a winner with this right here. Negative 0.4, negative 19.80. Negative 0.4, comma, negative 19.80. Again, you said negative 19.81, fine. Domain, easy point. Negative infinity, positive infinity. Range, now we do have to look at this. So my graph is going all the way down. So I do have negative infinity here. But this is not going up to positive infinity. I definitely have a cap. Now, again, despite the way my graph looks, if I drew this a little bit more accurate, probably should have had that curve go up a little higher to be a little more accurate, because we can see, hey, this only goes to 4.85 or 4.83. This goes up past 20. I was like, that one on the right is definitely higher, but I have to look at my points here. That number is higher. That means that's going to be the highest this can go. So 20.96. And since I can be that number, I'm going to include a bracket there. There you have it. Like that's it. That's all we got. Again, I know these problems take some time. I definitely understand that that these problems take time. On your test, I'm not planning on making it timed, because I understand that yeah, it was like, this takes some time. I mean, just typing these in can take some time. So with all that, I completely understand. Like, don't stress about the time. So now let's take a look at this guy here. Notice I just wrote zeros. We're still going to find everything else. See, I just wrote it on the next page. I was like, but I just wanted to start with the zeros. Start talking about the zeros of this guy. Y equals x to the third plus 3x squared minus 9x minus 2. So if I go ahead, and this time, should be right. I'm going to double check that I'm not an idiot. Minus 9x minus 2. Awesome. I was like, we can see the graph. Take a quick look at the graph here. But something I want you to notice, if you're having trouble seeing it, I'll point it out to you. When you look at this graph here, okay, again, that looks like it's 2, but when I look at this, those don't quite look like nice, pretty zeros. So as I'm scrolling through here, I'm not finding zeros on that negative side. That other guy looked like he was around 0. I'm not finding zeros. I'm not finding a 0 around 0. I do find a 0 here. I do find one of my zeros. Okay, so I know 2 is a 0. Great. So I can go ahead. 2. There's a 0. It's a 2. Okay. Well, since that's one of my zeros, I saw on the graph crossed 3 times. There are 3 zeros in this problem, but I was only able to find one of them. Well, when that's the case, when I'm only able to find one of my zeros, then what I need to do is I need to go ahead and start dividing. So in this case, I go ahead. Now, as a factor, okay, if we're talking about this as a factor, here's what I want to point out. This factor, that would be x minus 2 as one of my factors, okay? Because if I set that equal to 0, that's when I get the positive 2. So when I go to divide, my key number here is 2. Something I didn't point out back when we were doing this because I didn't want to add complexity on complexity on complexity, but hopefully we're up to this point where it makes sense. When I do synthetic division, the 0 and the key number are the same thing. Those are the same things. So I'm still going to divide 1, 3, -9, -2. I told you guys back last semester, we are going to be using synthetic division. We used it last chapter to help us identify those slant asymptotes. Now we're using it this semester to help us figure out what the heck is going on in this problem. So I bring down the 1. 2 times 1, I get 2. Add that down, I get 5. 2 times 5 is 10. Add that down, I get 1. 2 times 1 is 2. You get a remainder of 0. I better get a remainder of 0, otherwise I did something wrong. Because we already knew it was a 0. That was confirmed for us in the XY chart. So what this means, that's an x squared to begin with. So I have x squared plus 5x plus 1. Well, looking at that, no wonder I didn't find any zeros. That's not factorable. I'm not going to get nice, pretty integer zeros out of this equation, out of this polynomial. Doesn't mean I can't get the zeros, just doesn't mean they're not going to be these nice integer zeros. I can use the quadratic formula. I can complete the square. Whichever you choose is up to you. I was like, I can tell you right now, it's going to be a little bit of a mess either way. You slice it. I was like, I'll just flat out tell you this one. Let's see, I'm just going to real quick in my head use the quadratic formula, and we get x equals -5 plus or minus the square root of 21 over 2. Those are our two zeros. Our two other zeros in this case are -5 plus the square root of 21 over 2 and -5 minus the square root of 21 over 2. Those are our two zeros. And that's okay. Nothing ever says we have to have nice integer zeros. Life is not that nice and neat. We're not always going to have nice, pretty things. We have to understand that, yeah, life is messy. Math mirrors life. It's not that what we're doing is any different. I was like, we've done this before, this idea of dividing to find these irrational zeros. The only difference was that, one, we were guessing what that number was. Now we have an XY chart to tell us what that is. I was like, but this is exactly what we did back when we were solving those polynomials. So that's what you need to understand. So when I'm doing this right here, I'm going to have 2, comma, -5 plus the square root of 21 over 2 and -5 minus the square root of 21 over 2. Those things remain the same. Like I said, just, yeah, it's not those nice, pretty numbers that we like seeing. I like steak. It doesn't mean I get it all the time. So we have to be ready for those. We have to make sure that we're looking carefully at these problems. If I don't see all the zeros I expect, but I see some, then that means, hey, I might need to go ahead and do some things like that. Now, we can approximate and we can figure out, okay, this is about, let's see, like this guy right here is about -0.3. And if I look at that chart right here and I look at about -0.3, we can see, yeah, I mean, I'm pretty close. I'm pretty close to 0. This guy's a little bit closer. I mean, so maybe it's a little bit closer to -0.2. But we can see, yeah, I get pretty close. The other guy if I did the -5 plus the square root of 21, that's close to 5. A little bit less than 5. It's a little bit less than 5, but or -5, I should say. And we can see, hey, look, yeah, I get pretty close to that. I get pretty close to a 0 at -4.8. So these do make sense when we actually look at the XY chart. But again, in terms of investigating here, dividing and then using our quadratic skills are what we're going to need on this problem. Now, we can do everything else. Everything else remains exactly the same. Okay, degree, 3, leading coefficient, 1. End behavior is, it's odd, it's even, or it's positive, down and up. Now, in terms of graphing this, I'm not overly worried about the graph right now. I'm not overly worried about the graph. I still think the graph is a great thing. Like I said, we said this was 1, 2, 3, 4, 5. We said this was a little bit less than 5. We said this was a little bit more technically than -5. A little bit less than 0 to. I still think the graph is a nice thing to kind of help give us a gauge, especially when we're finding that relative max and relative min. But if we understand, okay, it's about these numbers, I'm going to have some maximum there, I'm going to have some minimum there. If you can visualize that in your head, then I'm okay with that idea. I'm okay with this. So that's just what I want you guys to understand with these problems here. So relative max. Let's go ahead. Again, we can see it's probably somewhere around 3-ish, -3-ish, I should say, sorry, based on what I have. So let's go ahead and let's investigate around -3, just see what's going on here. So we get 25. Hey, look, I was like, 25 is definitely higher than those decimals there. So my exact maximum in this problem is -3, 25. That's pretty interesting that we're just at -3, 25 for that maximum. Again, that was just kind of neat. That's all I want to point out, that we have a nice, pretty integer maximum. We didn't have any decimals. So let's go ahead and let's look at that minimum. Again, we suspect that minimum is probably somewhere around 1. So when I go ahead and, wrong button. When I go ahead and I look around 1, we see -7. And hey, look, I was like, we see 1, -7. So look at that. We had messy zeros, but our relative max and min were nice and pretty. Will that happen all the time? No, that won't happen all the time. I was like, that was by design. I designed this problem to be that way, where yes, these guys were not the prettiest, but these guys weren't bad. So that's what I wanted you to understand in this problem is that, hey, there are certain things that yeah, this wasn't so pretty, this was pretty. Usually there's a balance in math. Usually if one thing is a little weird, that made another thing nice. Okay? I'm not saying we can't have nice zeros and nice relative max and mins. It's not impossible to have that. But like I said, just doesn't happen too often. So domain and range, obvious domain, range, I'm going down, I'm going up, I'm hitting everything in between. So in both these cases, -50, +50. That's the big idea. We're going to be dividing now. So let's go ahead, try the dividing on your own. Go ahead and try this dividing on your own here. I was like, see if you can find those zeros. Type that into the sheet. See what you get here. I was like, I already have it done. No, it'll work. All right. So hopefully you've tried this problem. So in trying this problem here, again, looking at the graph is not a terrible thing. I think I have a 0 at -3. Let's go ahead and confirm that over on the XY chart. Scrolling all the way down, -3. Yep, we do in fact see a 0. Great. So if I'm thinking factoring here, if I'm thinking in terms of factoring, then that means this is going to be x plus 3. Remember, my factor is kind of the opposite of my 0, if you will. So for my key number here, that means -3, 1, 7, 11, -3. Remember, those numbers just come from the coefficients. Bring down the 1, -3 times 1, -3, add that down and get 4. -3 times 4, -12, add that down, -1. -3 times -1 is 3, 0. Great! Because again, if it's not 0, I screwed up. So then right here, x squared plus 4x minus 1. Complete the square quadratic formula. I'm not writing those steps because we at this point should have that mastered. If you do not, please reach out to me and make sure that you're saying, hey, Mr. Keith, can you help me with this completing the square stuff because I don't know how to do it, or quadratic formula. Please let me know, because right now, to me, I look at this. I'm not saying everyone should be that everyone should be to the point where they don't even have to write anything down. But I just know right away this is x equals -2 plus or minus the square root of 5. Like I said, I'm doing a lot of work in my head. I'm not saying everyone should be able to do that without work. But because I'm kind of good at completing the square, like I told you guys to get better at completing the square, I can do that problem in my head in 5 seconds. So right here are my -2 plus the square root of 5, -2 minus the square root of 5. I have my zeros. Now again, I have another sheet. We'll write them all here. -3 and then -2 plus the square root of 5, -2 minus the square root of 5. And again, this right here, this is, because that's a little bit bigger than 2, so this is, again, -2 plus a little bit bigger than 2, so this is about 0, a little bit bigger, and this is about -4. And if we look at our chart here, or not our chart, sorry, if we look at our graph, we can see, yeah, a little bit bigger than 0, I said a little bit bigger, a little bit smaller than -4. Smaller is definitely the more accurate term there. So, great. Everything matches up. Degree 3, leading coefficient 1, so end behavior is down and up. Relative max, relative min, we're going to go to the chart for that. We know it's going to be, again, just to the left of -3 for the max. So when I'm looking, that graph doesn't get too terribly far away from the 0, but we can see that I have some 1.4s. That's definitely the highest right there. So -3.7, 1.47, 1.48. -3.7. Right, I put the, okay. I doubt myself, guys. I doubt myself that I'm remembering numbers writing back and forth here. Oh, shoot. Now, this is an oversight on my part because I wrote min first. Did I do that on the last problem? No, that's weird. Okay, make sure that you are labeling things properly. I'm going to pretend like this was planned the whole time, that I was planning on this. Make sure that wherever I ask you the max, that you leave that. Now on your test, I'm going to be consistent because your test, I'm working on, I don't have it perfected yet, but your test is going to be on Math Excel. You're going to type these things in here. I'm consistent in every single one of those problems. If I say relative max first, relative max is list, like the way I list these things, I'm pretty sure it's the same way I'm going to list them all on your test. So there was our relative max. Just make sure you label them. I don't want to have to take off points because you flipped those and now it's like, dang it. You don't know. You're not telling me you don't understand what a max and a min are. All right. Now we still need the minimum there, which we said was probably around. Like I said, it was probably around -2, -1.5, just by looking at the graph there. Let's see, get to -5, -1.5, -1, I get all the way to 8. Oh, look, hey, that one ended up being nice and pretty. That's cool. Because we can see -7 all around it. -1, -8. Now, I didn't sketch the graph because, again, we kind of looked at the graph. I'll be perfectly honest, at the time of recording this, I have not decided if I'm going to have you actually turn in the graphs or not. Like I said, it's kind of one of those, like, I go back and forth. Do I want you to do the graph? I don't want you to do the graph. I don't know. So there you go. Dividing. If I have any good zeros, I want to make sure that I'm dividing. That's the important thing. All right. One more problem. Now notice this is x to the 4th. So when I look at problem 4 here, looking at my graph, I would say that one looks all right. That one looks all right. Notice that, hey, my graph doesn't go like incredibly, horribly out of the way. It stays kind of compact. The closer the zeros are, the less we tend to get further away. So, but again, I would say probably about -4 and -2 is where I'm thinking, just using that graph as a guide. So let's confirm that. -4, yep, there's a 0. And then -2, yep, there's a 0. So cool, I know -4 and -2. Now you might be thinking, well, Mr. Keith, if we have 2 zeros, I mean, even if I write those as a factor, even if I write down x plus 4 and x plus 2, how am I going to get that? Successive division. We talked about that as well. I'm going to divide by one number and then divide by another number. So when I divide by this, I'll start with the -4. It doesn't matter which one you start with. We're going to end up in the same spot either way. 8, 15, -14, -40. Bring down the 1. -4 times 1 is -4. Add that down, I get 4. -4 times 4 is -16. Add that down, you get -1. -4 times -1 is 4. Add that down, -10. And -4 times -10 is 40. I get a 0. Great. Now I just keep that same string of numbers I just got. I don't reset. Okay, just reminding you. I know we didn't do a ton of these problems back then, but we did do some. Now I just keep dividing. I just do that again. I bring down the 1. -2 times 1 is -2. Add that down and get 2. -2 times -2 is -4. Add that down, I get -5. -2 times -5 is 10. Hey, great, a 0. And this right here at the bottom, again, that was x to the 4th. This is x to the 3rd. This is x squared. So I have x squared plus 2x minus 5. And again, with a little bit of work here, again, that I'm not showing, but I expect that you guys can do here, with a little bit of work, I know that this is going to be x equals -1 plus or minus the square root of 6. -1 plus the square root of 6, -1 minus the square root of 6. So now all that work that I just did here, I can go ahead and translate and say, okay, -4, -2, -1 plus the square root of 6, negative 1 minus the square root of 6. Again, if you want to sketch the graph, sketch the graph. We kind of already looked at it a little bit on the XY chart, so it's not a big deal. Degree is 4. Why did I write 3? Leading coefficient 1, end behavior is up and up. I can see that my end behavior is going in the same direction. So that's going to tell me, okay, something fishy is going on with my range here. So I need to make sure my range is not just going to be negative infinity, positive infinity. Relative max. Well, for that, again, I need to kind of go back to my chart. Okay. This is where, again, sketching the graph might help you out here. Looking at the graph, whichever you want to do here. So when I'm looking at this for that maximum, 1, 2, again, it looks like it's about, it's in between negative 2 and negative 3. So I want to make sure I'm looking in between negative 3 and negative 2 for that highest number. Now it's not getting that high. So right here we can see, hey, at negative 2.6, I have 2.8869. So right there, hey, you know what? I was like, this is it. This is higher than all the other numbers around. Sometimes those numbers get really, really close. So just be aware of that. Negative 2.6, comma 2.8889, whichever. Negative 2.6, comma 2.8. I'll say 9. I'll round this time. I should be more consistent, but I'm not. All right, and then again, for the minimums here, I see, hey, here's a bunch of negatives. We saw in the graph, it doesn't get that far below. It doesn't get that far below. So when I'm looking at this, hey, there's my 0. I was like, that negative 1 minus the square root of 6 was about negative 3.5, which we can see, hey, that's close to 0. So I'm just looking in between these two numbers. Again, it's tight. It's tight. The difference is 0.01, but this is still lower. So I definitely want negative 3.8, negative 0.66. Now, from the graph, we know that, hey, there were 2 minimums. So I'm looking for another minimum here so I can see, okay, well, hey, negative 38, negative 39, these are all in the 40s. These guys are lower. So who's the lowest? Again, I got to look closely here. Negative 6.2, negative 6.6, and then negative 1.8. This guy right here, 0.4. 0.4, comma, negative 42.66. Negative 0.4, comma, negative, I already forgot the number. Negative 42.66. Now for domain, again, easy point. Negative infinity, positive infinity. Again, if I did just a quick little makeshift graph here, something like that. Again, this guy went way lower. So I'm looking for, hey, how low did that point? It wasn't negative. Why did I write negative? Sorry, folks. That's not a negative 4. My apologies. Copy that down. 0.4, comma, negative 42.66. Okay. So for my range, go ahead and I don't get all the way down. This is as low as I get. So negative 42.66. And I can be that number so I have a bracket, but it's going all the way up So I'm going to infinity. Now, I know I might be talking a little bit fast. I'm trying to slow down on the things that are new. Okay, I don't want these videos, I don't want to give you a bunch of 15-minute videos and all this. Like I said, I want to try to. I know that the last video went a little bit longer than I meant to. This video is about as on par with where I wanted it to be. I want to make sure that we have a good understanding. Make sure that was the last problem. Making sure we have a good understanding of this. The only new thing, everything else is stuff we did in the previous lessons. The only new thing is this idea of dividing. This idea of saying, something funky's going on here. Let's figure that out. All right. Again, work on the assignments. On top of that, I'm just mentioning it. If you want to wait until after we've covered everything, that's fine, because I can't remember exactly what the problems look like. But there are some problems on Math Excel. There's 2 problems on Math Excel. One, that is going to be a graded assignment. So make sure you do those 2 problems on Math Excel. The reason I gave you that is because I want you to see what your test questions are going to look like. I know that I gave you a bunch of worksheets. I still want you to do those worksheets. Those worksheets are great practice. Okay, make sure that you're doing those worksheets. But I want you to also do those 2 things so that way you know how to type stuff in on Math Excel in terms of your answers, and secondly, I want to make sure that you know what those test questions are going to look like. That's why I want to put those on there. So that's all I got. On that note, I will bid you adieu. Until next time, stay safe out there, Afton.